Hello everyone, welcome to Brainwaves. I'm Brandon Stagel and I'm your host and I'm Communications Director for IMRO One Mind Institute. Today on Brainwaves we're going to talk about new frontiers in depression treatment research. Says William Styron in his memoir, Darkness Visible, the pain of severe depression is quite unimaginable to those who've not suffered it, and it kills in many instances because its anguish can no longer be borne. Depression in its major stages possesses no quickly available remedy. Failure of alleviation is one of the most distressing factors of the disorder as it reveals itself to the victim, and one that helps situate it squarely in the category of grave diseases. Indeed, about 35,000 lives in the U.S. each year are lost to suicide. Depression treatments need to be improved. Fortunately, we have three leaders in the field of depression research here with us today to tell us about their exciting work. Dr. Kafi Jirasa, a 2013 IMRO Janssen Rising Star Translational Research Award winner, is here with us today. Kaf, thanks for being here.
Thanks for having me.
Absolutely, you're welcome. Dr. Stepney Dulawa, 2014 winner of the IMRO Depression Research Award in memory of George Largay, is here with us today. Stephanie, thank you.
Hi, thanks for having me.
You're so welcome. You're so welcome. And Dr. Nelson Freimer, a leader of UCLA's Depression Grand Challenge Project, is here with us today to tell us about his research too. Nelson, thanks so much for being here.
It's really a pleasure, Brandon.
Awesome. Thanks, Nelson. So I'll start by asking each of our guests, each of you, to introduce yourselves, tell us a little bit about the research that you're doing related to depression. And then viewers, I'm going to ask them some questions. If you have any questions at any time, you would post them on the Hangout by clicking on your little Q&A icon on the screen. So, Dr. Kafi Jirasa, do you want to start? Can you please give us a quick intro to yourself, your work, and your Rising Star funded research vis-a-vis depression?
Yeah, absolutely. Thanks again, Brendan, for the kind and warm introduction. So I am a neurobiologist, psychiatrist, and bioengineer at Duke University, and I'm particularly interested in understanding how information processing changes in the brain in the illnesses we call depression and bipolar disorder. In particular, I think of the brain as a networked, almost like a computer. And so we seek to understand how communication within this network, or this computer that we call the brain, changes in the context of depression. If we can understand how those electrical patterns or electrical rhythms that your brain uses to communicate changes in the context of this illness, then we can come up with new diagnostics for depression and bipolar disorder. The second part of what we're seeking to do is, once we have diagnostics based on brain rhythms and electrical patterns in the brain, can we come up with treatments based on using electricity to reset these brain electrical rhythms. Now, the use of electricity to think about brain illnesses has been around for quite some time. The classic history, the treatment with it that we think of is ECT. This has been one of the most widely available and effective treatments for depression for quite some time. The problem is it has a large number of side effects that comes along with it. And our hope is that by tuning this sort of treatment, with the goal of resetting and tuning electrical rhythms, by tuning this and miniaturizing it, we can come up with what essentially would be pacemakers for depression and bipolar disorder.
Wow, that sounds exciting. And I know I've heard about it before, but it always makes me feel a little bit in awe thinking about that prospect. So thanks, Kat, for that introduction. So, Dr. Stepney Dulawa, can you please tell us a little bit about yourself and your research vis-a-vis depression with Rising Star Award funding?
Thanks, Brandon. I'd love to. So I'm an associate professor in psychiatry at the University of Chicago, and I'm a basic scientist. My lab has been studying the mechanisms of the antidepressant effect and also its onset. And one major problem with all current antidepressants that are used is that they require weeks of continuous treatment to begin working. So my lab recently identified serotonin 2C receptor antagonists as putative fast onset antidepressants, which begin working within days within our mouse models. So the IMRO Rising Star Award in memory of George Largay, which I was awarded, is funding work in my lab to identify the mechanisms by which these serotonin 2C antagonists induce their fast onset antidepressant effects. And it's already clear from the work that we've done so far that the mechanism of these agents is very different from that of current antidepressants such as the SSRIs that are currently in use.
That's exciting to hear, Stephanie. I'm glad you made some useful progress so far. Good job. Thank you. So, Dr. Nelson Freimer, can you please introduce yourself and your research and tell us a bit about your participation in UCLA's Depression Grand Challenge?
Yes, thank you, Ben. I'd be very happy to. So I am by training a psychiatrist, and I've had more than 25 years of experience as both a treater and researcher of depression, bipolar disorder, and other mood disorders. But I'm also a geneticist and have worked for the same period of time on looking for the genetic variations that contribute to bipolar disorder, depression, and other mental illnesses, including schizophrenia. And at UCLA, where I'm a professor in the Department of Psychiatry in the Semel Institute, I also direct the Center for Neurobehavioral Genetics, which aims to really understand the genetic contribution to all of these diseases. But what I'm really most excited about now is an effort that I've been helping to lead over the last 2 years, which is, as you said, called the UCLA Grand Challenge of Depression. And this is an effort that is occupying our entire campus and will, over the next 10 to 15 years, to really bring together researchers, clinical specialists, and really the entire campus community, from students to staff to faculty to those who get treated in our health system, all with the goal of working together to try to first decrease and then ultimately eliminate the enormous debilitating effect and burden that depression has on individuals and on our community. And so we're going to be undertaking a research program that aims to both achieve a greater understanding of the fundamental biological basis of depression, trying to understand the genetic contributors to depression in the largest study that will have yet been undertaken of depression, and then to, at the same time, use the information that we gain to begin instituting treatments and other novel interventions on a larger scale than has previously been possible to really try to have a maximal impact. And this, of course, is something we won't be doing alone at UCLA, but we'll be engaging partners from other universities and institutions both throughout the country and the world, as well as partners from industry and government that really have the same goal in mind.
Nelson, thanks for explaining the Grand Challenge and your work with it. It's just an amazing initiative that UCLA is putting together, and so I'm looking forward to seeing what comes out of it. So it's time for some questions. So each of you is investigating depression at different levels so that better treatments and someday cures can be developed. I'll start with you, Stephanie.
Yes.
Stephanie, so your Rising Star Research Award is somewhat translational as well as basic, but you're working to develop, as you said, faster onset medications to treat depression by understanding specific neuromolecular mechanisms, that 5-HT2C receptor mechanism. But you've also talked about how ultimately curing depression will require a deep understanding of the many different subtypes of depression and what causes them, what the causes are of different subtypes. So can you please explain a bit how understanding causes of depression is so important and how it's helped inform your work with the Rising Star Award? And also, can you talk a bit about the range of different depression risk factors that scientists will need to consider in order to develop a comprehensive means to treat depression in all its different subtypes?
Sure, Brennan. So first of all, to address your question about genetics, so I work primarily in the mouse, and I can say that actually understanding mouse genetics has been important in helping us to develop some of the basic research models that we're using in the lab to study the mechanisms of antidepressants and how they work. However, I think that in the future, the kind of work that Nelson is talking about is going to be really critical, because perhaps in the future, genetic tests for humans, in theory, could become available, which could pinpoint, for example, which type of antidepressant a particular patient might respond to. But before this sort of thing is possible, we're going to have to really understand, the whole genetic architecture of depression, and a lot more studies and a lot more larger samples are going to have to be collected to gain that kind of information. In terms of what other kinds of depression risk factors will we need to understand to develop a comprehensive mean to treat different kinds of depression, this is highly complex. There are likely many different subtypes of depression with many different causes. I think aside from genetic risk factors, I'll just briefly mention, I think it'll be important, for example, to understand sex differences in depression. So, for example, women are twice as likely as men to develop depression, and the postpartum period and the perimenopausal period are very high-risk periods for women. But at the same time, men that become depressed are actually twice as likely to succeed in committing suicide compared to women. So I think that it's possible, theoretically in the future, that we may need to identify different treatment strategies for some of these subtypes that might affect certain men or certain women differently. But I think there are a lot of different subtypes that will have to be better characterized.
Thank you, Stephanie. That's a great explanation, and I agree that personalized medicine will be a very important way to treat mental illness going forward. It's not just one cookie-cutter disease. It's so many different factors that can come in from the environment, from one's genes, from one's early life. So yeah, that's very true. Also, you mentioned the importance of understanding genetics, and Nelson, let's go to you next. You're doing research, your main research focuses in your own lab on genetics, as you mentioned, and I've seen that our understanding of the genetics of depression is actually much less developed than that of our understanding of the genetics of schizophrenia. I mean, it's been discovered that there's about 108 different genes known to be involved in the risk for schizophrenia, but I don't know how many are involved in depression, but not nearly that many as far as we know of, that is to say. I'm sure there are many, but we just don't know what they are. So can you please explain a little bit why, what needs to be done to accelerate depression genetics research, and why the understanding genetics can be a key for developing better treatment someday?
Yeah, so I'd be happy to do that, Brennan. So first, I completely agree with your comment that we've made much more progress in understanding the genetic contribution to schizophrenia than we have for depression. And I think that there are two main reasons for this. One is relating to something which Stephanie said, which is that depression really is a catch-all term that probably involves many different subtypes, all of which have a different causation, and that means both causation at the level of genetic contribution as well as causation at the level of experience. And it's not surprising that that's true. Depression is something which is much, much more common than schizophrenia. Schizophrenia is something that affects about 1 out of every 100 people. Depression is something which over the lifetime affects more than 10 out of 100 people, maybe as many as 20 out of 100 people. So something which is as common as that, it's not surprising that it has a much more diverse makeup, and that's true at the genetic level as well as at the level of the experiences that contribute to it. So it's going to be much harder to identify the specific genetic contributors, and that's going to require a very, very large number of people to participate in the research. And so, so we believe it's probably going to take upwards of 100,000 people participating in very comprehensive genetic studies to identify the genes that are contributing to depression. And of course, that's one of the major motivations for the Depression Grand Challenge at UCLA that I've mentioned. So that's one of the factors, is that it's probably a more complicated disease, a series of diseases than is schizophrenia, and it's going to require a very large number of people to make progress. The second part of the equation is one that frankly is not based on the science, but really is based on on what you might consider the sort of the politics of the way in which science works, which is that we just haven't had the will of doing the large-scale studies of depression that we have for other diseases, not just schizophrenia and other mental illnesses, but diseases throughout all of medicine and health. In fact, people have done studies that have indicated that given the toll that depression takes on people and on the society, that it's the single most underfunded disorder in terms of the research commitment that's been made to it. And so we just haven't put the money in to actually doing these large-scale genetic studies that we have for other diseases throughout medicine. And so it's really necessary for us to have the will to really put together these studies on such a large scale to really understand something as complex as depression. And then you might ask, why is it so important that we do so? And I think the answer really is going back to schizophrenia, the example that you mentioned. A few years ago, we really had just guesses as to what the biological underpinnings of schizophrenia were. We thought that there was a strong genetic basis, but that was really at that point entirely conjecture. Now we can actually point, even though none of these genes on their own causes schizophrenia, they each contribute in a little to a little degree to schizophrenia. They're telling us something about the biology in the brain and throughout the body that may be going awry to cause schizophrenia. And so similarly, once we begin identifying specific genes that contribute to depression, we will have an entryway into studying the basic biology of depression, developing new treatments that we don't currently have.
Fantastic, thank you, Nelson. And that makes sense. And that once you understand the mechanisms, you can target specific points, as Stepney's doing already in her research, to develop targeted treatments that are not developed by accident, but are developed by actual will and adherence to theory and knowledge about the way it's actually working. So that makes a lot of sense. So we actually had a question come in from a viewer named Walla Walla Tri-Cities. It looks like it's a DBSA, Depression Bipolar Support Alliance chapter. And the question is, can you comment on the recent discovery of a blood test at Northwestern University that can not only diagnose depression, but also who will respond to CBT? Are any of you familiar with that blood test?
I'm not tremendously familiar with it.
Okay. Does it sound like the kind of thing that is within the realm of what you know about how depression works and is diagnosed?
So I can say I suspect that it will be significantly more complicated than having a simple blood test, both in terms of diagnosing depression and predicting individual treatment responses. I can certainly say there's some preliminary studies that have been done by a group out of Emory, which has been looking at brain imaging scans and predicting and who will respond both to a classic antidepressant treatment. This is with an SSRI versus classic CBT. And in this case, there are certainly biological signatures that showed up in this case which predicted or which correlated with how one responded to being randomized to one treatment or another. I did have a couple thoughts on challenges to translation that I think could give some insights to how one would even think about the question that was just posed. And so when we talk about depression and depression research in general, I think one of the biggest challenges we have is depression by its very nature is a human neuropsychiatric disorder. And so I say that with the caveat that I do a lot of animal research, but by its very nature and how we think about it and how it's defined, it is a human brain illness. And so the challenge becomes how we develop and think even about modeling this in an animal. When you talk about what depression could be, based on the way we diagnose this, there's some studies and papers that have been written about this. There are about 1,497 combinations of patterns of symptoms that you could have that could show up in depression. Now, this means we could be dealing with 1,497 combinations of illness, or we can be dealing with a smaller group of illnesses that manifest in a broad category of ways. So the same illness affects different people differentially, or we could be talking about different illnesses. The other major challenge that we have, and I think it's certainly something that is raised by the blood test, is that while it's clear that depression certainly involves the brain, it doesn't mean that the manifestation of the illness we call depression solely resides in the brain. Right? Like with many other illnesses in the body, it's pretty clear that things that happen in our body, whether it's something like systemic inflammation or changes in your thyroid function, they can produce manifestations of illness that look very similar to depression. In fact, sometimes we do blood tests to make sure those things aren't going on before we can diagnose somebody with depression. So I think the challenge of what this illness is and how individuals will respond will ultimately require something greater than a blood test. It will require something that likely involves their genetics. It will likely involve getting a really good psychiatric history in terms of their experiences in the past, likely some sort of molecular markers from a blood test, and imaging will likely be layered on top of that in the end.
Okay, thank you, Kath. That's a really good comprehensive explanation of that. I also wanted to mention that when I was thinking about this question, it reminded me of the work of Dr. Scott Russo, who's also funded by IMRO, and that is to understand the inflammatory factors involved in depression as governed by the immune system. And it may be that the test that the viewer, Walla Tri-Cities, is referring to might be a test for inflammatory factors in the blood, which would indicate that somebody would be susceptible to depression based on an inflammatory mechanism. That's just conjecture on my part. So thank you, Walla Tri-Cities, for your question. So and everyone, thanks for your answers. So Kath, you were talking about diagnosing depression and many factors involved in diagnosing depression. I know that your work with the Rising Star Award that you received from IMRO and Janssen is enabling you to find. It enabled you so far in your lab to find an electrical signature in the brain. I believe it's related to the connection between the amygdala and the prefrontal cortex in the brain, and this enables you to detect whether someone might be susceptible. I believe you're looking at mice here, but might be susceptible to depression in the face of chronic and extreme stress. Can you tell us a bit about this mechanism and how it is you've happened upon this mechanism through the work with electrical circuits?
Yeah, so we operate on a hypothesis in the lab, and that is when we have these neuropsychiatric disorders, these complex illnesses in humans, that they have a convergence point, right? And our hypothesis is that the convergence point, it happens somewhere in the brain, right? And so by thinking of the brain as a complex networked organization system, we think that this convergence point, it disrupts the brain's ability to signal information, and that this is reflected in the electrical patterns that we see in the brain. And so we had set out to study, it's a social stress model that really we think gives a good equivalent model of an animal model of PTSD and depressive symptoms. And so what happens is animals are exposed to a pattern of stress in this case. And after being exposed to the pattern of stress, we have some animals that are able to tolerate this stress, and those animals are called, we describe them as resilient animals, and another group of animals, in essentially the brothers of the animals that are able to tolerate this stress, they are susceptible. In other words, the stress has an effect on them that changes their ability to process rewards, so they no longer like sugar. It changes their ability to maintain homeostasis in terms of sleep and metabolic function, and they get this long-lasting fear response and anxiety as well. And so those are the susceptible animals. And so we know that this happens as a result of being exposed to the stress. The real question we had was, were these animals actually different before they were stressed? And all the stress was doing was unmasking their individual differences in behavior. Studies have been done in humans using imaging tools like functional magnetic resonance imaging, where they've looked at how one's amygdala, this is what has classically been thought to be a part of the brain's fear system, how the amygdala responds electrophysiologically in terms of how much blood it needs when you show it fearful faces, neutral faces, angry faces, and that this has been linked to anxiety. And so we wanted to ask this question: if we looked at the electrophysiological patterns of the responses in amygdala and prefrontal cortex, part of the brain that interacts directly with the amygdala, could we find a pattern of electrical brain rhythms that said whether animals would become susceptible or show a susceptible phenotype after stress or show the resilient phenotype? There are a couple of things that were pretty important about this study. First of all, these animals were, for all intents and purposes, genetically identical. So these were animals that were on a pure strain background, genetically identical, that were, in theory, bred and came into the lab in the same condition. Behaviorally, we couldn't distinguish them from one another before they were stressed, but they had a clear electrophysiological difference in their brain, and that was how the amygdala and the prefrontal cortex reached a balance with each other. This balance said when the animals were stressed, the ones that it required too much prefrontal cortex to control the amygdala before they were stressed, those are the ones that were stress susceptible. And the ones where the prefrontal cortex wasn't working very hard to control the amygdala before stress, those were the ones that were stress resilient. And the way I think about this is a house in the middle of summer, right? You've got your AC on, and it's, you know, a great 78 degrees in the house. Well, the harder the AC is working to keep it at 78 degrees, it is then not able to tolerate the increase in heat outside. If the AC isn't working very hard to keep the system at steady state or the 78 degrees, then it's much more tolerant to the changes in the environment as well. So the idea here is that the brain, it reaches this electrophysiological homeostatic set point, and that dictates how one will respond to stress. Now, we have no idea how the brain ends up different in these animals and where in the lifespan this change happens, but that's the sort of question that we're asking now.
That's exciting. To figure that the set point of somebody, perhaps in humans as well, that's conjecture right now, would make sense. Somebody's homeostatic set point would determine whether they're able to be susceptible to stress or not, or be resilient in the face of stress. That makes a lot of sense, and I think that that will hopefully produce some good diagnostic improvements. So thank you. We actually had a couple of new messages come in from Walla Walla Tri-Cities. They say, visit our Facebook page, Depression Bipolar Support Alliance Walla Walla, for a link to the study they referenced about the blood test for depression, susceptibility, and resilience to response to CBT. They also cite a Chapel Hill, North Carolina, UNC School of Medicine study. Researchers have shown that brain scans can predict which patients with clinical depression are most likely to benefit from a specific kind of talk therapy. A study which was published today, looks like they're quoting a February 4th news item. So, Kath, is that the brain scan study you were talking about?
Yeah, so the one I was referring to was a group out of Emory.
Okay.
That had undertaken this. But it is the same principle of looking at a signature of the brain and essentially randomizing people to a treatment, then say, was that signature predictive in who would respond in either which way when you go back and look at it.
Cool, very cool.
Yeah, I think what's important to make note of when we talk about studies are it is important to make sure that when we're talking about a study that's diagnostic, that it's both specific, so in other words, it is specific to the illness, and it's sensitive. In other words, if the illness is there, the screening tool will pick it up. And ultimately, it requires us validating this across larger and larger populations such that we don't make large treatment decisions based on false positive studies. So I'm always a proponent of large-scale validation.
Thank you, Kat, for that caveat. And it makes sense that one small study is encouraging, but we need larger studies to confirm that and bring the discovery into general clinical use. So, and that's why it's so great what UCLA has started to do with the Depression Brand Challenge, to bring scientists together to work on a large-scale study. So questions. I have a few questions for all of you, and you can all answer in turn, or whoever wants to take these first. Actually, I did have one question I wanted to ask you, Kat, before I moved into the questions for all. And that is, if someone's depression susceptibility can be identified early before a major depressive episode, what steps can they take personally in concert with their doctor to strengthen their resilience?
Yeah, so this is something we think about a lot, even, especially given that our animal studies suggest that there are differences in stress susceptibility before stress ever occurs. One of the reasons why this is particularly important is a clear clinical observation that I had was that stress played a major role in the onset and exacerbation of the majority of neuropsychiatric illnesses that I would encounter patients suffering from in the clinic. And so it's hard for me to give good clinical advice about what one could do to increase their resilience and increase their ability to prevent developing a neuropsychiatric illness down the line. I would certainly suggest if one has risk factors, these risk factors could include things like family members with a neuropsychiatric illness. If they find that they're having a difficult time dealing with stress and sleeping, I would certainly encourage them to visit and see a psychiatrist. There are general things that I think are good brain function. These are things that are simple as exercising and having a well-balanced diet, making sure one is sleeping as well. And those are certainly things I would recommend generally.
Thank you, Kath. I dropped off for a moment there. I'm not sure if the broadcast continued, but I'm back now. So you were saying there are general things that someone can do after to enhance their wellness. Could you repeat that, please?
Yeah, those are things that, you know, I'm sure our parents have been telling us since we were young. Exercising, sleeping well, eating well, and certainly exercising the mind, like challenging the mind, reading, taking on new ideas as well. I think these are things that are generally very important for brain function.
Sounds great. Words to the wise. Thank you. So now to our questions for all. What do you see as the biggest hurdle or hurdles that research in our society faces to building an understanding of depression sufficient to someday better treat and cure depression? And what do we need to do to surmount these? Who would like to go first?
I can go.
Great.
I think, you know, one thing that really needs to be addressed is just simply the way that healthcare is administered, because this itself can pose a large barrier to effectively treating depression. And so Kath, you know, mentioned earlier the importance of cognitive behavioral therapy in addition to pharmacological treatment. Unfortunately, many times, you know, individuals wind up having a very brief appointment with their GP, who then kind of prescribes them, you know, an antidepressant, but follow-up is, you know, can be practically non-existent. So I think even once we have, you know, better treatments, it's a matter of how we can effectively get them out to all of the public.
Yeah, there needs to be more funding for and more institution of more psychiatric beds and outpatient community treatment centers. I totally agree with you there. So we did have, let's see, another question. Are there other research disciplines besides neuroscience which can be brought to bear on the depression problem? In what specific ways can collaboration among scientists accelerate the search for cures and better treatments for depression? Nelson, do you want to talk about this?
Yeah, I'd love to talk about that, because that is, as you know, Brandon, that is really the essence of what we're trying to accomplish in this grand challenge. And I think that it can be looked at in a number of different levels. One is just going back to a point that Kath made, which is that that depression is probably not just a disease of the brain, but is a disease of the brain in relationship to the whole body. And you know, and he mentioned the specifics about inflammation, and you know, and you also raised a question about that. So I think that on one level we need the involvement of both basic and clinical researchers from throughout the world of medicine and health. We know that depression very frequently occurs in the context of other common diseases like cancer, heart disease, other brain diseases like stroke or Parkinson's disease. So one thing is that we really need to engage people from all of these disciplines to be working together to be focusing on depression. People who study inflammation, people who study infectious disease, all of these different ways in which you know, you can get perturbations of body systems which may manifest in depression. You know, going to the point that Stepney made, which is that there's this huge issue of you know, of the follow-up and the way in which people get into the healthcare system, the degree to which people can stay in treatment. So we need the involvement of people who study health economics, what we can do in our healthcare delivery system to increase the likelihood that people will actually get recognized for having depression and then treated for it. We need to increase the involvement of groups that know how to communicate about depression to the public. and certainly groups like IMRO and One Mind, play an important role here. But we've seen this in other diseases like cancer. 20 to 30 years ago, when I was first starting out, it's hard to believe now, but people were as reluctant to talk about cancer as they are now to talk about depression. And because of the fact that people made such an effort to talk about cancer, or AIDS, HIV is another example. The people that were most concerned about this really made sure that it became part of the discussion throughout all the places where healthcare decisions are made, where policy decisions are made. We need to do the same thing for depression. So we need people who are knowledgeable about policy, people who are knowledgeable about communication. All of these types of groups have to work together.
Thank you, Nelson. And it also comes down to each of us to, if we're experiencing depression, to talk to our family, our friends about it, and not be ashamed of it as something that we live with or have to deal with as a disease. It is a brain disease that affects our physiology and affects our mind as a corollary, and we need to get help for it when we have the disease, and also let other people know that it's okay. There's nothing to be ashamed of to have something like depression. And then you mentioned also that we need to build public awareness. So places like the DBSA, which you have a viewer online, Walla Tri-Cities DBSA, can certainly help in that as well. This viewer has posted one more question related to his previous question. He says, "My question is, if in fact a test shows a person will not respond to CBT, what other options could be used for the treatment, especially in view of the nurture aspect of depression?" And that dovetails with the question I wanted to ask too. So who would like to take that one?
I can say, I think that just because nurture is involved as well in potentially inducing depressive episodes, that doesn't mean that it has to be treated environmentally as well. So it's very possible that a pharmacological agent could actually be successful in treating a disease entity that is actually caused by nurture, if that makes sense.
It does, in that the brain and the mind are just two sides of the same coin. And for example, it's known that for example, CBT can change neural pathways in the brain. Cognitive training can change neural pathways in the brain. Other treatments for depression that I know of, emerging treatments for depression, include repetitive transcranial magnetic stimulation. I know that's been shown to be effective and is actually used as a first-line treatment in some cases now. And also, let's see, meditation. There have been some studies that show that meditation can be effective in treating mild depression, although that's not what it's aimed to do, but it can do that, according to these studies, which are criticized, but the studies exist. Does anyone have any comments on those two modalities? Okay, that's fine. I'll be the spokesperson just to mention those. Great. So, is there anything? Thank you all for your answers to these questions. Is there anything else anyone would like to add about depression and research on it?
Yeah, I'll just say I think when we're talking about neuropsychiatric illnesses like depression, families play such an important role of helping their loved ones to get care, and equally as an important role in advocating for larger societal change that lead to improved health outcomes. This is advocating for improved research investment, advocating for policy changes. One of the tragic aspects of neuropsychiatric illnesses is sometimes they can take away people's ability to advocate and speak for themselves. And so the family plays such a critical role in really advancing treatment and hope for these illnesses. So I certainly want to thank all the family members out there.
Thank you, Kat. That's a great thing to say, and I agree. I do have one more question from a viewer, Cindy Dyer here at IMRO. She's watching. Thanks, Cindy. Question is, regarding Stepney's research, is the potential for faster onset drugs to help treat depression shaping up for a specific type or level of depression at this point?
I'm sorry. So could you repeat that to me one more time, Brandon?
Yeah, sure. So the question is the potential for faster onset drugs to help treat depression shaping up for a specific type or level of depression? Maybe she means like a specific causal factor, or a specific severity of depression.
I don't think that we have answers to that quite yet. A lot of the studies that have been done, although some of the studies that have been done with ketamine, for example, were done in patients that had more severe and more treatment-resistant depression. And that's sort of because, you know, ethically, when you're trying a new agent, you're going to try in a population like that. You're not going to just try it in some individual that hasn't had any other trials of antidepressants. So we know that, for example, ketamine is effective in people with more severe depression. However, ketamine has not been approved for use. So that was only done in some trials that were done at NIH, and it creates a lot of problematic side effects. So, so right now it's basically you know, we're doing a lot of work to try to identify, again, other sort of safer, faster-acting drugs. I think it's going to take some time to go from the mouse studies, then to find similar agents that can be given to humans and evaluate their safety, and so on. But that is the goal of my IMRO Rising Star Award. And I think the research is very promising, but it is going to take some time to go from the preclinical to the actual clinical trials in humans.
Thank you, Stephanie. Yeah, so everyone sit tight, do your best to keep your wellness well, and maybe use some of those ideas that Kath mentioned regarding wellness to keep feeling as stable as you can. So everyone, thank you for watching and for being a part of this discussion today. And I'll keep you updated on new developments in depression research as new discoveries come in from IMRO scientists and other scientists on IMRO social media. If you have any questions that you weren't able to ask today, please join us on IMRO's Brainwaves page, and I posted a link to this on the Google Hangout event. It's imro.org/brain-waves, but the link is there on the event. And these three scientists will answer your questions in a blog-style format there over the next 3 days through Friday, March 20th, 2015. Kath and Steph and Nelson, thank you so much for being a part of this discussion. And looks like actually we do have one more question that has come in just at the last moment. Do you have a moment more?
Of course.
Okay, thank you. The question is, we have several members, this is Walla Walla Tri-Cities DBSA, we have several members in our 4 support groups that we offer in Washington that refuse to take medications because of bad experiences with side effects or a life choice to never take drugs and frankly not working. What can we suggest to someone like that? That's a tough question. It's something that so many people with mental illness deal with. I have schizophrenia. I was diagnosed in 1990, and when I was diagnosed, I did not want to take medications. I was kind of against it as a philosophical thing, and concerned about what it might do to my health and my body. But I can, and to my mind, and I can tell you that when I accepted that I had an illness that could be treated with scientifically based, evidence-based treatments, which I did believe had efficacy, then I did take the medications and I got a lot better. Of course, everybody's case is different, but that was my story. And so also when I was first ill, my parents were very adamant to making sure that I took the medications that I was prescribed, although I did work with my doctor to find the right ones that worked best for me.
Well, I think that's an important point, Brandon. It sometimes does take a lot of perseverance, but it is important to stay engaged with treatment. So no matter what the illness is, the consequences of not getting treatment and all the terrible things that can happen from that are usually worse. And so even though there may be side effects, it's really worth persevering to finally find the right one. As you've experienced, it makes all the difference to have that perseverance.
Yeah, it does. Yeah, thank you, Nelson. And perhaps my experience can be an example of that working. And thanks for that vote of confidence, Nelson. Great. All right. So Kafui, Stephanie, and Nelson, thanks so much for your insights today, for your presence, and for your work in finding better depression treatments and understanding depression better. So I appreciate you being here. Viewers, thank you so much for participating. And hope to see you next time on Brainwaves. Thank you.
Okay, well, thank you, Brandon.
Having us.
Thanks a lot.
Thank you. Take care.